Welcome to lecture series on data structures. In today's lecture, let us discuss about linked list implementation. So in the previous lecture, we have seen how linked list differs from array-based implementation. We have discussed about its advantage as well as disadvantage. Now let us go straight into the topic. So linked list is an ordered collection of elements. We refer each element in the list as node, and each node contains two fields. One is data field and other one is the pointer field. So the pointer field is represented using the keyword next. So the data field contains the data of element that you need to store in the list. In each node in the data field, you can store only one value. You cannot store all the values into a single data field. So each data field will hold only one value. And in the next field, it contains the address of the next node. Since, as I have said before, each node or each data in the linked list is connected with the help of pointers. So pointer obviously refers to the address. So the next field contains the address of the next node. So this will provide the link for the next node. So advantage of linked list is that as we discussed before, insertion and deletion of element can be done more easily, and it uses dynamic memory location, whereas array uses static memory location. When compared to array, memory utilization is efficient in case of linked list, since there will not be any wastage of memory. But still, there are few drawbacks when you implement anything using linked list. So the drawbacks are linked list does not support random access unlike array. If you want to store the next field also, still you require some memory. So it doesn't mean it does not require any memory. Though insertion and deletion will consume less time in case of linked list implementation, searching process will take more time, unlike array implementation. In array-based implementation, searching is much easier. There are three main types of linked list. One is singly linked list. It is also called as one-way list. Other one is doubly linked list. It is also called as two-way list. And third one is circular linked list. So array implementation, we have static memory allocation. Array has static memory allocation, whereas linked list has dynamic memory allocation. So what is meant by dynamic memory allocation is that it is a process of allocating memory to a variable during the execution of program or at runtime. There are four library routines which will help in accomplishing this function. Dynamic memory allocation gives best performance in situations when we do not have memory requirement, when we do not know the memory requirement in advance. Following are the four library functions that are used to automatically allocate memory at runtime. First one is malloc function. So the malloc function it reserves a block of memory of specified size and returns a pointer of type void. It allocates memory and returns a pointer to the first byte of allocated space. Whereas ELOC function, it reserves a memory at runtime. It is used to request multiple blocks of storage, each of same size. It allocates a space for an array of elements, initializes them to 0, and returns a pointer to the memory. Free, it is used to free the previously allocated memory, whereas it is also used to release a block of, we can also say it is used to release block of memory. A realloc function, it is used to alter the size of previously allocated memory. So at times the memory allocated by using a malloc function or a calloc function may be insufficient or it may be in excess. So in both situation, you can always use a realloc function to change the size of memory which is already allocated by malloc or calloc function. So this process is called as reallocation of memory. So these are the four library functions which is used for memory allocation in linked list. So I'll give an overview of what is singly linked list, what is doubly linked list, and circular linked list. We will discuss about the operations in detail in next videos. In case of singly linked list, it consists of this name singly doubly comes from the number of pointer field it has. In singly, you will have only one pointer field, one data field, and one next field. But in case of, if you see doubly linked list, So this is doubly linked list. So it has two pointer field, one previous pointer and next pointer, right? So previous pointer is used for pointing to the previous node, and next pointer is pointing to the used for pointing to the next node in the list. So it has two pointers. However, both singly linked list as well as doubly linked list has only one data field. The name comes from the number of pointer field it has. So singly linked list has only one pointer field, and that is why it is called as one-way linked list. Doubly linked list has two pointer field, and it is called as two-way two-way list. In case of circular linked list is again a doubly linked list in which first node and last node are linked together. In doubly linked list, there is no connection between first and last node, but in case of circular linked list, there is a connection between a first node and the last node. So these are the various linked lists. So in the next videos, we will discuss about each linked list and its operation in detail. Thanks for watching.